You are given a quantitative reasoning question. Now you have the samples, at least two of the samples. Yeah. One of the samples, you studied it, and then you understood how to get just one part in that sample. Using that part that you now know how to get, you looked at the second sample, and you also understood that the way you got the other part in the first sample is still the same way you get this part in the second sample. And then you shook your head. Yes, you said to yourself, I have arrived. I think I am ready to answer the exercise questions now. Okay. You went into the exercises, all right, and then you started answering them. Then maybe you met a particular question under that exercise, and you noticed that, you are lost. What you knew about how to get this part of the sample does not apply to this other part. You give up. Oh my God, I didn't know what to do again. Is that how difficult quantitative reasoning is? Well, in today's class, I'll be teaching you what you need to know about quantitative reasoning. And I want to tell you this, it's very simple, okay? Quantitative reasoning is very simple. As a matter of fact, when you know just one part in a given sample in a quantitative reasoning problem, you can use the knowledge of just that one part to answer everything in the exercise question without any stress. So I am welcoming you to our quantitative reasoning class. Now on the board, if you look at this, what you have there as the topic is Introduction to Simple Equation. Introduction to Simple Equation. We treat this topic also in mathematics. What business does simple equation have in quantitative reasoning? Oh yes, I think this is where a lot of people get it all wrong. Okay? One of the first steps to survive quantitative reasoning problem is to know that most of the problems we face in quantitative reasoning are actually simple equation. Once you know how to handle simple equation very well, then I am telling you that you are going to enjoy solving quantitative reasoning problem. In fact, it will become like a game to you. I hope you are ready for today's class. Let us get to business. When we talk about quantitative reasoning, what is it all about? I wrote something here on the board that it is an aspect of mathematics that helps someone to reason on the relationship or connection between quantities. Is that not interesting? So you see that quantitative reasoning, no matter the name given to the subject, it is actually mathematics. So I say it's an aspect of mathematics. And good enough, quantitative is simple equation aspect of mathematics. If you do not know that before now, I am telling you this now, that quantitative reasoning is simple equation part of mathematics. So a good knowledge of simple equation in mathematics will help you to be able to handle any problem you see in quantitative reasoning. Because here, in quantitative reasoning, it is simply a part of mathematics that helps us to reason on how quantities are related, how quantities are connected. That sample you usually see, maybe in your textbook, they'll give you at least two samples, one, two, A or B, and then A and B rather. Then you look at it, how do I get this part? If you have no need, you come to the second sample to confirm that what you actually taught in the first sample is still the same. You compare when both of them agrees, you can now start solving your question. The exercise is given to you. So the way those quantities are connected, the way those quantities are related, quantitative reasoning is the part of mathematics that helps us to think about that. If I give you, let's say, 2, 3, and 6, I may choose to say, okay, give you another sample, you have 4, 3, and 12. If you go to the 2, 3, and 6, and you check the sample, you may just start thinking, okay, 2 times 3 is equal to 6. If you come to the second sample, where you had 4, 3, 12. Now, if the way you read the first sample is 2 times 3 equal to 6, which somehow agrees with the first sample, you come to the second sample and you check 4, 3, 12. Okay, if I do 4 times 3, will it give me 12? Because that's the way I went about the first sample. So if I do 4 times 3 equal to 12, I would now jump up and say, yes, I've gotten it. The second sample has confirmed the first sample. Because in the arrangement, once again, 2, 3, 6. 2 times 3 equal to 6. The second sample now, 4, 3, 12. 4 times 3 equal to 12. The two samples, the way I read them, the way I moved, gave me an answer that agrees. So I'll start jubilating and start solving my problem. Now, this thing you read, 2 times 3 equal to 6. 4 times 3 equal to 12. The question now is, can you be able to convert it, to write it in a simple equation form? If your answer is yes, that thing can be written in a simple equation form, boom, then you are really set to solve any problem, any question given to you under that exercise. What do I mean by all of the things I have said so far? Quantitative reasoning, take major, let's say 95% of it is all about simple equation. Well, I would like to tell you the two parts of quantitative reasoning. I've been talking about the part that deals with simple equation. I had to focus more on that. In fact, that is what this class will be based on, to help develop you in the aspect of simple equation, because with that, any problem we have in quantitative reasoning will be solved. But then, you should know that quantitative reasoning has two parts. Let us look at the parts. We have them on board. Alright? One of the parts is the calculation part. And that calculation part is where we make use of simple equation. And then the second part is the coding and decoding part. I say that again, coding and decoding part. Where sometimes somebody might tell you, okay, you are given, let's say, quantitative. And then under that spelling, quantitative, they now write under it 1, 2, 3, 4, 5, 6, down to the last letter in quantitative. Maybe say Q is 1, U 2, A 3, N 4, T 5, I 6. T still goes with 5 there, then A goes with this. They just give them numbers, alright? We refer to that as coding and decoding. That part usually don't give us too much trouble, and so we'll just talk about that sometime in other classes. For today, in this video, I want us to focus on the calculation part of quantitative reasoning, where I say we make use of simple words, equation. Question: what do we need to know about simple equation? We are going to talk about that. These are the principles that you need to know when dealing with simple equations. We refer to them as basic principles. One of them is you should know about collecting of like terms. Collecting of like terms. We're going to use CLT to represent that. So when you are dealing with simple equations, there are problems, questions that will be given to you, and you need to do what we call collect like terms. The second principle is cross-multiplying. Cross-multiply. We're going to use CM for it. Again, there are some simple equation problem that will be given to you that will require that you do cross multiplication. Then principle number 3 you should know is that which we call dividing both sides of an equation by the coefficient of the unknown. I'll explain all these things as we are moving on. That dividing both sides, we use DPS for it. So once you know these 3 principles, I guess you're really ready. I believe you will now be set to handle any problem under simple equation as well as quantitative reasoning. So now, I'll be talking about simple equation properly now, and then we'll see how it relates to quantitative reasoning. Alright, I will be starting by asking you a question. What is simple equation? What is simple equation? So on the board here, I have a definition of simple equation. It is a mathematical statement that tells you that a quantity or an expression is equal to another quantity or another expression. Now, when you talk about quantities, you talk about expression. In mathematics, they mean about the same thing, okay? They mean the same thing. Quantities, expressions are just the numbers, the alphabets we use in the study of mathematics. For example, if I tell you maybe 2x, 2x is an expression, is a quantity, it is a term, T-E-R-M. We use any of these words to refer to something in mathematics, okay? To a number, to alphabet in mathematics. So that's the meaning of expression, quantity, or term. So simple equation is just a statement that tells you that this thing is equal to the other one. Whenever you see a simple equation, how do you identify it? Simple equation must have this sign, equal to. A simple equation must have what? Equal to. This is the sign there, you know. Now that equal to divides every equation into two parts. The left hand side and the right hand side. Is that okay? The left hand side and the what? Right hand side. So always remember this. If you see a mathematical statement, how you will get to know that this is an equation is when you see equal to there. And that equal to separates or divides that equation into two parts. The left and the what? Right. Does that make sense? Let us see some examples of simple equations here on the board. I have x equal to 5. It's a simple equation. X there is a term, is a quantity, is an expression, and it's equal to 5. 5 is another term, is another quantity. Now this statement is telling you that x is equal to 5. And you notice that this equal to divides this equation into two parts. From here to this direction is the left hand side, LHS. And then from here to this part is the right hand side, RHS. Let us look at another example. X plus 3 equal to 6. This is also another equation. You have the left hand side and the right hand side. That equal to sign, that equality sign separates or divides this equation into two parts. Now, from this part, this is the beginning of the equal to, you know that. So from that side to the left is your left hand side of the equation. And then from this side, you know, this is the end point of the equal to sign. So from that side this way is the right hand side of the equation. RHS, right hand side. I hope you are following what I'm saying. If you have any question, quickly send a question. Go to your personal platform with the GMAS 41 and then send your question. Is that okay? You can make a voice note, you can type the question, you can write the question on paper, snap and send. You decide whichever that is okay by you. Now, I have told you what simple equation is. I've also told you that a simple equation is always separated or divided into two parts, the left hand side and the right hand side. I've given you some examples here on the board. I've also shown you how you can identify the left and the right hand side. Let's continue with some other examples we have here. We have y minus 4 equal to 9. So what are the terms on the left hand side? Y minus 4 equal to 9. Okay, that's good. Y and minus 4 are on the left hand side. And then 9 is the term, the quantity on the right hand side. We have 2a equal to 10. 2a is on the left and 10 on the right. Now look at another equation, 7x minus 2 equal to x plus 10. There is also another equation. The left hand side, what do we have there? You are very correct. 7x minus 2. That's what we have on the left hand side. Then on the right hand side, we have what? X plus 10. Look at another equation here. T over 3 equal to 8. T over 3 equal to 8. Then look at another one here. 5c over 2 equal to 15 over 6. So you see that in each of these simple equations, we have two sides, the left-hand side and the right-hand side. And we also have alphabets there, you know. The alphabets, we call them unknown. We call them what? Unknown. You don't know their value. In fact, when dealing with simple equation, it is those unknown that you are looking for. That is what you want to get their value. Alright, let us move on. We want to look at equations involving collection of like terms. We are using CLT for it. Remember I told you that when you are dealing with simple equations, there are three basic principles you need. One is collecting like terms, CLT. The other is cross multiplying, CM. And then the third principle is dividing both sides by the coefficient of the unknown, DBS. Now you know what you know the unknown now, as in you know the meaning of an unknown in a simple equation. I told you already all these alphabets, okay? So when we say divide both sides by coefficient of the unknown, well, coefficient is that thing, the number, the things multiplying the unknown. Let me quickly show you an example. Like here I have 2a equal to 10. A is the unknown. So coefficient of the unknown here is this 2 multiplying this a. Is that okay? Don't worry, we'll come to that when we start treating equation involving dividing both sides by coefficient of the unknown. Alright? Now I want us to focus on this. How do you identify equations that could involve collecting like terms? And when you identify that this particular problem given to me, to solve it I need to collect like terms, what are some other things you also need to know? On the board here, I have three things I want you to be very, very interested in when dealing with equations involving collection of like terms. Number one, how would you know that this simple equation given to me, I have to collect like terms? Whenever you see plus, minus, you know, these two mathematical signs, plus, minus, in any question that's a simple equation, then you should know that likely you have to collect like term. That is, you may collect like term in that question. A quick example, let's go back to this. Now look at this. X plus 3 equal to 6. You can see there is plus there. So somehow we have to collect like terms here. Now we have this y minus 4 equal to 9. We have to collect like term as well, so you can see minus there. What about this? 7x minus 2 equal to x plus 10. We will have to collect like terms here because we have plus and what? Minus. Let me ask you a question. 2a equal to 10. Do you collect any like term here? Do you use that word collect like terms? No. There is no plus here, there is no minus combining any two terms there. Look at this one, t over 3 equal to 8. Do you collect like terms there? Again, no. There is no minus or plus that joins two quantities together here. So you don't collect like terms in problems like this. Even in this one, you don't collect like terms. We will treat what you do to problems like that as we move on. Remember, now, I'm telling you about what? Equations involving collection of like terms. So when a simple equation is given to you, you see plus and minus there, then start thinking that you will have to collect like terms. Please, dear student, do not wait for someone to tell you that here you have to collect like terms. When you see plus and minus in a simple equation, start thinking that somehow you need to apply the principle of collecting like terms. Number two, I've been talking about like terms, like terms, like terms. What are these like terms? Like terms are terms that have the same letters, that is alphabets. Also, if you have numbers, they are also what? Like terms. So you see there are two conditions for identifying like terms. When you see the same alphabets, they are like terms. Now when you see numbers are also like terms. Please, to help you understand this quickly, let us go back here again. We have x plus 3 equal to 6. Did you see that you have number here? So these numbers are like terms. 3 and 6 are like terms. X here does not have any like term here because there is no other x here. Is that okay? Now these 3 and 6, they are like terms. So from this number 2 point here, you have to collect like terms. Okay, so you need to know that like terms are terms that have the same alphabet or maybe numbers. They are like terms. And what is expected is for you to collect the like terms together. Like terms should go to one side of the equation. So like in this case now, you notice that on the left hand side you have x and you have another number there. Then on the right hand side you have number. So it is expected that you remove this number from the left, take it to the right to go and meet the other number there. So that x will be left alone on the left hand side. Okay, let me quickly show you this. 7x minus 2 equal to x plus 10. Did you identify like terms there? Are there things that have the same letters, alphabets there? That's good, yes. 7x and x. You can see there is x here. There is also x here. But you see this x, which carries 7, is on the left. Then this x here is 1x. There is invisible 1 here. If it is 1 times a number, we don't write the 1. So this is 1x. Now this x, you have to take it from the right hand side, move it to the left hand side to go and meet this 7x. Then you notice that if you remove this 10 from here, this x rather, if you remove this x from here, 10, which is the number, will be left. Did you notice that there is a like term of 10? We have a number here, and the number is what? This minus 2. This minus 2 is on the left hand side. So you have to do what? Remove it from the left and take it to the right, so as to go and meet this 10. We are going to do all of those things. Don't worry. Let's just get the principles, okay, the guidelines first. Number 3. When you are collecting these like terms, you know, numbers or alphabets will be crossing equality sign. Like this one, I say this x should be taken to the left. If you are moving this x to the left, it must cross this equal to. I also told you that this minus 2 is a number. It is a like term of this 10. So this minus 2 will be taken from the left to come to the what? Right. If you are to move, let's assume that you hold this 2 now and you are dragging it to the right hand side. It must cross this equal to. When numbers are crossing equal to or alphabets, you want to take note of this. And what is that thing that you need to take note of? Positive number crosses equality sign. It changes to negative. Are you saying that? So if you have plus a number or plus an alphabet crossing equality sign, it will change to what? Minus, where it is crossing to. It will change to negative, which is minus. Then, we have also there, negative number crosses equality sign and changes to what? Positive. So if you have minus a number, and that minus a number is crossing equal to sign, that minus will change to what? Plus, where it is crossing to. I will give you a quick example, okay? I'll give you a quick example. Here we have on the board. This is 7x minus 2 equal to x plus 10. 7x minus 2 equal to x plus 10. I told you that we have to move x to the left hand side to meet 7x. And I told you we have to move minus 2 to go to the right hand side to meet 10. Okay, if I want to move this x here is plus x. There is no minus here. So when I give you something and there is no minus, that thing is plus. So if this plus x is a positive term now, is a positive quantity, if it is to move to the left hand side, it will cross this equal to sign. And because this plus has crossed this equal to, it will change to what? Minus here. So you now have 7x minus x. When this x goes to the left, what you have on the left will now become 7x minus x. Now, I also told you that minus 2 will cross to the right hand side to meet 10. This 2 here is carrying minus. You can see just before the 2 you have minus. So this minus belongs to 2. As this minus 2 is moving to the right, it will cross this equality sign. So, the minus 2 coming to the right will change to what? Plus 2. So that on the right hand side, you now have what? 10 plus 2. So in all, from what I explained here, what you will now get is 7x minus x equal to 10 plus 2. And you have collected your like terms. All that is left is for you to now solve and get the value of x. So that is what this point 3 is explaining. Is that okay? Once again, positive number crosses equality sign, it changes to negative. Then negative number crosses equality sign and changes to what? Positive. Remember, negative means minus, positive means plus. These are the things you need to know when dealing with equations involving collection of like terms. We shall pick questions now on quantitative reasoning and see how we can solve it using this knowledge.